Hi everyone, and welcome to the CAD Dimensions 3D Printing Podcast. And today's podcast is extra special because we're trying new things. We've been doing this podcast for a while, so we all sat down and asked some very difficult questions. What do we want this podcast to do? What do we want people to learn from it? What do we want the takeaways to be? What does our audience want? What do we want? And we came up with a slightly different format. We've mostly been a news podcast, and you'll get a little bit of news towards the end of this. But we broke it down into 5 segments, and so we're gonna see what you all think of it. You see, at CAD Dimensions, we want to empower engineers everywhere with the best tools possible that then allow them to impact the world in whatever ways they do. My name's Adam Fosnot. I'm a mechanical engineer, and I was hired here to be a 3D printing expert. Joining me, we'll start with...
I'm Kevin Keefe. I'm the marketing manager here.
And we also have...
Ken Postal, another application engineer.
And behind the cameras is...
Hey everybody, I'm Ben. Also, I just want you to look. We all have actual microphones now.
I know. Look at this.
Yeah.
We don't have to snuggle up
Thank
real close.
you again, YouTube, for a 4th microphone.
I know, right?
I remember when our first podcast, we were huddled around a single microphone.
Yeah. We've grown up a lot.
Standing. This is way more comfortable.
Oh, I forgot about sitting. You were the one standing, and then the one person was sitting, so we're all trying to be the same height. We didn't even have enough
We've
chairs.
come so far.
If you've been with us since the very beginning, thank you for your support. You make it all possible. Anyway, our very first segment comes to us from Ben. And he has a thought-provoking question for us.
I have no answers.
No answers?
Well, I have a couple answers. I have a few questions.
Just questions?
Okay, let's go.
Yeah. What are some of your biggest myths about 3D printing? Let me rephrase that. What are some of your top myths that you've heard about 3D printing? I'm going to cut that last section.
Okay. I'm going to go ahead and start because this one hits close to home with a customer that came to us recently. And that is the myth that a lot of people seem to have in their heads where you can 3D print something like a standard part cheaper than you can just go buy it off the shelf.
So the assumption is that I'm able to make it from a 3D printer cheaper than buying it myself.
Yes.
In all cases, just ubiquitously for everybody.
Yes. Now,
Probably not best advice, huh?
It's not the best advice, but it's nuanced in a way because in some cases that's true, but in a lot of cases it's nowhere close to true. Like there's a reason why we don't 3D print forks because they're widely available and they're cheap and that sort of thing. Similarly, little things like phone holders or desk organizers.
There's things that are otherwise mass produced, right?
Yes.
Yeah.
Yes. Even something like replacement boat parts, replacement drone parts, replacement car parts. Usually the manufacturers make those and they're readily available for, you may not be happy to pay, $10 for a replacement plastic piece, but it's still going to be cheaper than reverse engineering it and 3D printing a replica in most cases. And so that's a myth that hits pretty close to home.
What do you think? If you have the CAD file and it's your property, it might be cheaper to create one of. But if you don't even have a CAD file of it and you're just trying to reverse engineer something, is that when it gets way more expensive?
The reverse engineering is definitely part of it. But I would go a step further and say that if you're just hypothesizing that you have a CAD model and it can be printed cheaper with no 3D printing exposure, and so you want to hire someone to print it for you, just go buy a replacement part. It's probably not going to be cheaper if you're trying to do it as a source.
I think that's the key part, though, is how much of the service you're actually, or how much of the work you're actually outsourcing.
Okay.
Now, like you said, if you have to both draw the part and export that as a service as well as the printing itself, there is cost to modeling.
Yes.
Someone's time. In some cases, I think like you were describing, like if you had like a toy drone and you didn't have the file, it might be cheaper just to go to the original manufacturer and buy the part for $1, $2, than try and make it yourself. On the flip side, if that manufacturer no longer makes that object or no one has any backups anywhere, okay, then your only option might be printing.
Right. If you have something rare or something really old that you need a replacement part for, maybe 3D printing makes sense. But it always depends on the situation. I feel like more often than not, when people come to us for replacement parts, they're looking for a way to like stick it to the manufacturer and like not buy the real one.
Shortcut things. Yeah.
Be like, oh, but I could 3D print that for $2 instead of paying $9 for the real one. And that's just not the case.
Their goal is lower overhead, not address the problem of I can't source these parts.
Right.
Yeah.
Right.
Car parts. You've had a lot of people ask you about car parts, right?
We have, actually. No, I was talking to Greg about some car parts for his Jeep recently. He wants to do like a custom air intake sort of thing.
Yeah, and in that particular case, it's custom. That's why you can't go to the store,
Right.
can't go to the car manufacturer and ask for one. You gotta make it yourself.
I've thought so many times because we just listed our house, so I've come into so many things where I'm like, I bet if I had like a 3D printer, I could make like a little thing like this to solve this one little problem or something like that. But it's like one-off cases and stuff like that. Or it's like a unique situation. It's not like I'm going to go to Lowe's and pick up something there that's going to cost me 28 cents versus printing it at home for 17 cents or something.
Right.
Yeah.
Right. But how many unique situations do you have?
Right.
And how much is your time worth to make the file to print the part?
Mm-hmm.
I once had not my current car, but a previous car where I 3D printed like some little, there was a rocker arm that, I don't know, it opened or closed something inside the door panel. And so I 3D printed a replacement part for it when I easily could have went and bought it off the shelf. But that's mostly because I had a printer and I have CAD skills and it was easier to do that way. But if I'm just like...
Stick it to the man.
Yeah. So I was able to stick it to the man, and I was a poor college student, so it made sense at the time. But I'm going to argue that for most people, it makes more sense to just go to AutoZone and spend $4 and get a replacement piece of plastic than going through all the hassle of drawing it and printing it yourself or having it printed.
So myth number 1, it is not always cheaper to 3D print something than to get it from the manufacturer.
Correct.
Right.
Beautiful summation, Kevin.
There you go.
Did you have a myth that you wanted to throw out there? Or were you relying on us to throw out the myths?
I do have another myth.
We all had myths?
Yeah.
Well, I didn't know if you did or not. I mean, I came up with 2.
Well, all right.
What do you have, Ben?
This is the first blog I ever wrote for CAD Dimensions. And I was trying to come up with different myths, but these ones keep coming up.
Okay.
3D printed organs. I have told a few different people outside of work, Stratasys can now print synthetic human tissue.
Okay.
Oh, so you can create organs. Well, you can create one that will not work well inside a person. I mean, you can put it in
Kinda.
see what happens. And every time I say that, someone thinks that we can now print living tissue.
Yeah.
Not synthetic. They don't even hear that word.
Right.
So yeah, there's kind of 2 branches to medical printing. There's like what we're doing with Stratasys, which is more of like medical simulation. So these models are never intended to go into a person. They're designed for someone to train or practice on or make educated decisions around using a model as opposed to just looking on a computer screen. The flip side of that, which is more still in the research theoretical stage, is the actual printing of living cells and organisms. Yeah. So like I've seen a couple examples, like I know I've seen printed ears, I've seen printed some other small
liver cell tissue.
Yeah, cell tissue.
It's not a working liver. It's just they're using liver tissue and then making it into a shape.
And it is something they're researching. They do want to get to a point where they could potentially produce organs because, there's a shortage of replacement organs. But that's still in a very theoretical stage. Like I said, what we're mainly working on is more like practice models and training surgeons, that kind of stuff.
Why do you think this 3D printed organ thing, like real organs, is so popular? Because
I have a theory on this.
Okay.
I want to hear your theory. I think you've thought this one out.
I have.
Okay.
The movie Face Off
I have not seen that movie.
Okay,
That is
so
a good movie.
So
Is it?
That's a really good movie. First of all, yeah.
Okay.
I don't want to like
Is
it as
it
much
about
as I do.
stealing faces?
So the idea is that
Okay.
John Travolta and Nick Cage are going to change identities entirely, and the way that they do it is there's a scene where Nick Cage gets his ear cut off, and there's a laser that runs over a bed of gelatinous goo, and then all of a sudden they can reattach his ear, right?
Okay.
That was the first time I ever thought like that's something you could do in science, like that's a cool application, and now to know that it's like potentially possible, that's cool. Like that's a cool
When
thing.
did this movie come out?
90s?
Like the 90s.
Okay.
90s, yeah.
I was an
Okay.
impressionable youth.
Yeah. If anyone in the audience has seen this
Guaranteed.
movie,
We get comments.
and thinks that this is why 3D printed organs are so popular, leave us a comment and say that you think Kevin is right.
Somebody validate me. Validate my feelings, please. This is what the internet's about, right?
I'm gonna
Yes.
stick with that. It's just the shortage of organs in general.
I don't agree
that
with
makes
you.
sense.
I like Kevin's answer better. It's more fun. I don't get it, but so often when I say 3D printing to like someone I've just met, they're like, "Oh, 3D printed organs." I'm
Yeah.
gonna say at least half the time.
That's almost all the time. Yeah, when I tell people that, like, "Oh, can you guys do stuff like that? Like you're making a heart in your lab?" I'm like, "No,
No. Almost nobody is doing that. It's in a lab setting, like at Carnegie Mellon.
And even then, it is a in those situations, it's a pile of cells. It's not a functioning organ that knows how to process things and do what it does.
Right.
Yeah,
Here's what I think.
It's so different.
but
I
it's
think
close.
that whenever someone says 3D printed organ testing, whatever it is in the news, people automatically think, oh, it's a finished product. And there's a lot of that. Facebook is a great place to share a lot of wrong information and really fun videos.
Yeah.
Mm-hmm.
I guess you're right. So much of what we see, I mean, it doesn't even have to be related to 3D printed organs or 3D printing in general, but so often a research video or a paper will get published and then it gets really popular online, but it's just research or it's just a company product announcement, and that product might not hit for another 2 years until it ships. It's just being announced. Same thing with research. Like they made a discovery, they got a patent, something like that, but that doesn't mean it's a commercially used product thing today, right?
Yeah.
Right.
But what is commercially available, sort of, it is, stuff you can practice on. The synthetic stuff, which is cool in its own right. And also, like my favorite, this is in my blog I wrote, that little girl holding up a model of her heart.
Yeah.
The heart surgeon worked on like a bunch of times before working on her own heart. I mean, that is share-worthy in itself. I don't think that you need to say, they printed 7 real functioning hearts of that little girl to do the surgery. No, it's cool enough that you can scan it and print a fake one.
Yeah, the important thing to emphasize with those kind of models is it's not something that we're expecting every doctor to have a 3D printed model to practice on before they do every surgery. There's some surgeries that are very routine to doctors, and it's not needed. But for those very rare and one-off cases where you're not really sure how exactly you're going to take on the problem, that's when it's most beneficial, because you can use that artificial simulation to practice or decide what you're going to do.
Right. Better surgeries, better medicine. That's all good stuff.
So myth number 2, while there are lots of applications for 3D printing in healthcare, we're still a little ways away from generating functioning organs from a 3D printer.
Correct. You're not going to be getting a 3D printed liver next year.
And the plagues of answering those questions
Who are you?
only reside with us. So.
Yes.
Who are you to say that?
Well,
I'm
Probably.
just a humble 3D printing nerd. Leave me alone.
By the way, hold on, one more thing. Shout out to Onion for creating the best organ donor video ever. They have this, like their fake news article, they're like, some wonderful donor has donated 1,000 livers and delivered it to our front door. Just thank you, whoever it is, the anonymous donor, like, please come back for more.
Oh my gosh. Terrible.
If you haven't seen that video, I suggest looking that one up.
Ben will link it in the description since he's such a big fan.
Yeah, why not?
Ken had an interesting myth that I think is worth going over, and then I got one more, and then we can move on to our next segment.
sure. I'll keep mine quick, but I guess the general myth is that 3D printing is like an instant, like when you print something, you get a part almost instantly. And I think that comes mostly from the name rapid prototyping. People think that, well, I put something in a printer, no matter how big it is, I'm going to get it in 5 minutes, 10 minutes. And that's not exactly true. It does take some time depending on the part, how much material you're putting down. But when we say rapid prototyping, that phrase is really in comparison to traditional manufacturing.
Right.
So how long does it take you if you don't necessarily have a CNC available right now to get a metal part or to get a plastic part?
So faster, just not as fast
Not
as some
instant.
people might expect.
There's like this, the most common one here is the Star Trek replicator. Like
Sure.
there's this like, oh, I press a button and this object immediately appears. That's not a reality yet.
Right.
Yeah.
But in comparison to traditional methods, depending on what you're trying to do, it can be significantly faster. It's
Sure.
just not an instant technology.
Do you think we're getting over that?
It's getting faster, much faster.
I mean,
The
more
expectation?
I mean more from an expectation standpoint.
As more people use it, yeah. I think that along with the technologies are getting faster, so that you're seeing some companies where you're printing a batch of parts in 20 minutes, 30 minutes, as opposed to hours now. That is feasible.
Yeah. I guess I do see that all the time where, depending on which company it is, sometimes when I'm visiting, they only call 3D printed parts RP parts or rapid prototype parts. Like that's their
Designation.
terminology,
Yeah.
and that's what they've been using for years. But I feel like it's misleading.
A little bit.
And I go to other companies where it's the complete opposite, right? And they understand 3D printing and they outsource from all different technologies, and so they understand that even if it's rapid in terms of it doesn't take 6 weeks to get from the machine shop, it's still a manufacturing process that takes time.
Maybe we should stop putting out videos at like 6,000 times the speed
Yeah, right.
of a 3D print. I'm guilty of that as well.
We're perpetuating this cycle.
No.
Yeah, because it's like done in 60 seconds for the video.
No
as long as
more
you-
time lapses.
Yeah. As long as
We're
you
calling it right
Time
now.
lapse in real time.
Yeah, as long as you say it's sped up, because I don't think anyone wants to sit around for a few hours to watch some of our things be printed.
I'll tell you what, especially when it's like, ooh, new 3D printing technology, something like that. A lot of those videos are sped up.
Right.
And they just like
They don't mention it.
Don't say it. So
Because they want to get to the end part to show you what it looks like without
Yeah.
losing your attention.
so much so that sometimes it fools me and I have to like dig through the article or something to be like, oh, the video is sped up 6 times. I'm like, now it makes sense.
Nobody mentions post-processing, which is the other part.
Right.
That too.
Like, do you have to cure parts? Do you have to soak them in tank? Do you have to
Tumble
spray
and
it or
paint
something?
'em,
Yeah, like
sand 'em.
what else goes into actually having that fancy, nice finished part that they show you at the end of the video?
Yeah. Yeah.
So myth number 3, 3D printing is fast, but it's not instant.
It's not Star Trek.
Yes.
Not Star Trek.
Not a Star Trek replicator, unfortunately. And then the last myth that I wanted to talk about reminds me so much of the organ thing, and that is that 3D printed food is the future.
Yeah, I don't think so either.
No?
Guess what? I went on Google Trends today.
And
And I
3D
looked-
printed food was up there, wasn't it?
I went, I looked up 3D printing and I went to Trends. Just guess what was number 1. We've already covered it once.
Guns.
3D printed steak.
Steak.
Again.
Yeah. I think we're much more likely to see mass-produced food from like artificial, like a lab, like lab-grown beef, lab-grown, flesh. Like there's applications for that. I think prior to, because you've got to have a feedstock that is food-based that can be extruded in a way that it's challenging to make it, appetizing that way.
It definitely is.
Right? Like, because I've never seen like something food 3D printed and said like that looks pretty good.
So
I'm
I
gonna eat
guess
that.
I guess the question I always think about when we talk about 3D printed food is, what is the benefit you gain from 3D printing it?
So like,
Like
yeah,
what is the purpose of
you're
like
just
other
repurposing food
Yeah.
from one form to another form. You're
Yeah.
not growing something.
Yeah.
You're not manufacturing
the only
something.
the only time I've ever seen an article about 3D printing food where I was like, wow, that's a good use was I think I saw in like Sweden or Norway or somewhere up in Northern Europe, they were taking like not ground food but more like pulverized food and trying to shape it back into the original so that people still had the sense that they were eating not just a bowl of mush, they were eating real food.
McDonald's McRib.
Yeah.
That's
so it was more for like senior.
Reconstituted flesh to look like a rib shape.
Yeah.
Now, why are they doing that, Ken? I'm guessing this is for people
Senior
that had
citizens,
trouble.
yeah,
Okay.
That's important detail, yeah. Important detail, yeah.
People
Good point.
not just eating reshaped mush for fun.
Yeah,
Like,
no.
they have a reason
Yeah.
behind it.
I like my bowl of mush.
Yeah.
It's more of a aesthetic thing than it is a functional thing.
Yeah, but I feel like most of the time I see trendy 3D printed food stuff, they don't acknowledge the why behind it. They're just like, look, we made a robot put cheese on a cracker.
Right.
It's 3D printing.
Our
but
pancakes or yeah.
But
Okay,
why?
those are cool. 3D printed pancakes.
3D printed pancakes are
is-
pretty
I don't know
cool.
about you. When I went to a diner as a kid, all I got were Mickey Mouse pancakes. Now I could get like a detailed Santa pancake. Heck yeah.
It's kind of like when I think of it, I think of it as a similar comparison to like those robotic bartenders. Cool, novel, but not really bringing a ton of value to the end product, I guess.
You want some more?
No, what I think does have value with 3D printing food are desserts, because desserts are supposed to look pretty. That's the whole thing behind it. So 3D printed chocolate,
3D printed ice cream. That's
ice
something you
cream,
could
cake,
do.
things that are supposed to look kind of fantastic. And
You guys are taking my
fairy tale.
myth and making it sound like it would be really cool, and now I'm upset about it.
I've
so
got a
thanks for
cool
that.
idea. What about a 5-axis robotic arm with a 3D printer that extrudes icing, and you can program like cake decorations?
They already have cake
No,
decorations.
Do they do
Kevin.
that?
Why?
I don't know. So my wife doesn't have to do it. She doesn't have to stand there with a piping bag and draw
The
stuff
point
on.
is, I think that it would be cool. It would be super cool. But it gets blown out of the proportions where people say, it's the future.
Yeah.
And when I think of something that broad of a statement, it sounds like we're all going to have it in our house,
Right.
printing food for us. Or we're going to go to a fast food restaurant and it's going to print me out a meal.
That's not the shape it's going to take.
No,
Yeah.
I'm not saying it'll never happen because you don't never say never, but that's certainly not the case
Yeah.
today. We're so far from that.
Again, if it was, I feel like it'd be more of a novelty than a functional
Right.
purpose.
Right.
So myth number 4: 3D printing food has its place, but it's not going to be mainstream anytime soon.
Exactly.
I hope not, anyway. Except in dessert.
Except in desserts. We can all get behind 3D printing
Yeah.
chocolate. That's fun. Everyone loves that. I think this is where we go to our next segment. Introduced by...
The four biggest myths. 4 is a weird number to have. We should do 5, 3.
Still eat one.
No, we'll do a bonus.
Okay. What's our bonus, Ben? I only thought of 2, so you're on the hook
We've
for
got
this last
like
minute.
15 minutes worth of myths.
Yeah, I think
Yeah,
we're good.
all right, we'll go to the next one. We can save
We can
myths
just
for next
delete
time.
one.
Even more.
More. Every podcast episode
Even
starts
more
with
myths.
myths. Myth busted. Anyway, Ken, what's our next segment all about? It is, I believe, the 3D printing application of the month.
Sure. Yeah. Okay. So, application. So we wanted to do just a quick segment to talk about, at least in some aspect of how people are using 3D printing. For this month, wanted to focus on a type of prototyping. Prototyping is by far the most well-known reason for doing 3D printing. Usually when people think of 3D printed prototypes, though, they think of visual models, form-fit models, something that doesn't usually have much more of a purpose other than just to hold and
Visual
see if the
aid.
geometry is correct. Yeah, just basics like that. Where we're seeing a lot more focus now and where we're getting more ROI value is in functional prototypes. So as time has progressed and materials have gotten better and machines have gotten better, we've been able to start printing higher strength materials, better chemical resistance, electric, I'm forgetting the word.
Static dissipated.
There you go.
Yes,
Yeah.
E.
And just better overall characteristics, mechanical performance, so that you can actually take parts, put them into a functioning design, test them, and either test a plastic component being your final part or a metal component like that, or use this as a predictor for your final component. So when I think of like an example of like maybe designing the shape of a turbine, testing it out of plastic, looking at how it handles flow, and then correlating that to how that would also act as a metal final part.
So what's in your hand, Ken? Is this an example of such a thing?
So
Of
this
a functional prototype?
Yeah, so that would be the nylon carbon fiber material, and I believe that one is a motorcycle.
Oh, it's a kickstand.
Yeah, like
or a kickstart.
Kickstarter.
Yep. Like a dirt bike, maybe.
Yeah.
Okay, so that's the foot pedal that would get.
So
this is.
Hey, you want to hold that up right in front of your mic?
So this is durable enough that if I was to affix this to a Kawasaki Ninja and use this as my kickstart, it's not gonna just come snapping off. I could probably get several hundred wears out of it because that's what you mean by functional prototype. It's got some meat to it.
I don't know if it's something you'd want to leave on there for 10, 15 years, but
Yeah.
to go out and test and, I don't know, a few times out on the track, run it a few times and decide, okay, is this a design I want? Yeah, it can do that now.
Right.
Where before, I'd say, I don't know, 10 years ago, we were mainly printing in stuff that would break almost instantly if you
So you could take it out of the research lab, take it to practical applications, and test it in real-world conditions there a little better.
Yeah,
Cool.
that's one thing I'm thinking when you say functional prototypes. Aren't all prototypes functional prototypes? If they don't function, what's the point?
I think what we're talking about with this particular type is when we're extracting some kind of data from these prototypes.
Okay.
Whether it be physical testing, mechanical performance, electrical, chemical resistance, like testing a system or testing an individual component and trying to decide, is that designed the best for the goal?
Okay.
Prototypes don't have to be functional.
They don't have to.
No, I mean, if it's supposed to look a certain way and you're just going off of I want to hold it and I just want to see if this feels right in my hand or if people respond the proper way.
Ergonomics.
Yeah.
Okay.
So that's more on the aesthetic side.
Yeah, aesthetics.
Aesthetic,
form or function.
visual, form, fit. Those are all, I'm going to say, you don't need a strong material for those. And so, just so that myself and the audience understands all this, functional prototypes are at the point with 3D printing today where we can print them with strong enough material to actually survive industrial prototyping needs.
Yeah.
Okay. Cool. This brings us to our next segment, I think, which goes really well into functional prototypes. With our 3D printing tip of the month, and I wanted to talk about how to make 3D prints stronger. You see, most 3D prints, FDM 3D prints at least, are hollow. Kevin, I'll have you hold this up.
Sure.
You held up the last part. And so most FDM, fused deposition modeling 3D prints, they're hollow on the inside, at least to some extent. And so this little brick has different infill patterns. Most 3D prints have shells on the outside, different outlines, and then they have infill, which is just like a grid or a honeycomb on the inside that supports the print itself so that it doesn't collapse onto itself. And depending on how you play with the settings around shells and infill will dictate how strong your part is.
And how much material you use, right?
And how much material you use, how heavy your part is,
How long it takes to print.
how long it takes to print.
How easily stuff passes through it, or lots
so
of considerations.
It's an important part of making strong models, functional prototypes, jigs and fixtures. A lot of the common uses for FDM printing is learning when to use what settings. It's easy and maybe a quick way out to say, well, I'm just going to print everything solid. I just want everything to be as strong as it could possibly be. But by doing that, you're going to waste material. Right? And so
I actually don't think I recorded it. I hit the pause button.
what a lot of people don't know, well, actually, I got to have you guess first. Kevin,
Yeah.
What do you think plays more into the strength of a 3D printed part? The shells on the outside or the infill on the inside?
Well, since we're talking about infill, I'm going to go ahead and say the infill
Okay.
real quick
of the part, because, I mean, that's really where you're going to get the structural durability. I mean,
you know
the
what-
shell could be
Do you know what we mean when we say shells or contours?
like the outside.
Right. So if you look at each of these squares, we can thicken that up.
Yeah, like the cell wall.
Got it. Okay.
Yes?
Yes.
Hey.
Kevin, you're doing great.
Look at that. The mitochondria is the powerhouse,
Is the powerhouse
of
of
the
the
cell.
cell.
Yeah.
and we're done. Yeah, I have to assume that, depending on, you could make these weaker or stronger, or they could have, break points in different places. Or these are so neat to me. You have about 1 million of these at your desk. I love checking this out all the time.
I'm guilty. If you're watching this video, pause right now. Leave your guess in the comments as to what has a bigger impact on strength of a 3D printed part, either the shells on the outside or the infill on the inside. I'll go ahead and wait.
Okay, you're good.
Ben, what's your guess? Shells or infill? What has a bigger impact?
Well, I'm just thinking about people, and we'd be pretty gross looking without skeletons. So, what is that? The skin would be the shell.
I guess
skeleton would be the.
You're right.
Yeah.
We'd
That's
also
a good
look,
analogy,
interesting
Ben.
take.
we'd also look pretty gross without skin, though. So,
But we'd be standing.
You'd still have a form. I mean, there's a museum of different cadavers without their skin, so you can see all their muscular structures.
Yeah, those gross me out.
Yeah,
No.
but it's still way better to look at than a pile of skin.
I'm confused how we got here.
Anyway,
This took a real weird
Yeah.
turn.
So,
Ben.
okay, well,
but
then
what
what's
I
the-
think is
what are
that
you
going-
getting at?
I
going
think
back.
infill is very important for structural integrity.
Gotcha. Well, Ken, you probably know the correct answer here. What's more important?
I would say it's slightly application dependent, but we usually see more impact from increasing the shell thickness.
Oh,
Dang
you
it.
trickster.
You tricked me.
Yeah, see, I distracted you guys with the fun infill patterns,
You
but
did.
that's the right answer. And so, typically, you see a bigger impact just by thickening up the outer shell.
So bigger impact. What does that mean? What do you mean by that?
So, by default, most 3D printing slicers only put 1 or 2 shells on the outside of a part, and then the inside is anywhere between 0 and 100% density of whatever pattern that you choose. And so if you take a part from 10% infill to 20% infill, just for example, that's not going to make the part as strong as adding an extra shell.
Gotcha. Okay.
We should test that. We did layer direction as a stress test,
We did.
but we didn't do infill and shell strengths.
Right. Well, that's because I already know the answer, Ben. That's why we're talking
Oh, yeah?
about it
All
now.
right, I'll just take your word for it.
Take my word for it. No, lots of people have tested this over time. Not that we shouldn't test it. It could be a fun use of an afternoon. But typically, shells have a bigger impact. This is for a few reasons. One, it's usually dependent on how the part is loaded in the application. But more often than not, the infill just supports the part. The actual shell distributes the force. On top of that, when you have shells next to each other, kind of being drawn right next to each other, the plastic can fuse together a little bit better because it's drawn along the exact same path, versus with these infill patterns, it's really only contacting the outside shell in a relatively small area.
There's less contact surface
Right.
between. Yeah, that makes
and
sense.
so the less surface area that you have in between tool paths means less adhesion between those tool paths, which means not as strong of a part.
Unless you anneal it.
Yeah, annealing's a whole separate topic that we're not getting into. Ben is so passionate.
He comes
about
back to
annealing.
quite often.
at least once every other month.
Now,
that he
I feel
brings
like,
up
yeah.
annealing.
The only flip to that rule would be as you add more and more shells, your stiffness is going to go up.
Sure.
So your durability may go down.
Right, and that's a
Naturally.
whole nother can of worms that we could get into, of stiffness versus durability versus impact strength versus tensile.
Adam, we got a whole new format. Don't give it all away at once.
Right, so we will get back to all of those wonderful topics in your next 3D printing tip of the month. But for right now, keep in mind that if you want to make a stronger part while still conserving material, you're probably better off increasing the shell thickness of your part compared to just increasing your infill density.
Thought-provoking question, Adam. Where's
Yes.
the AI that gives you the ideal infill pattern based on what your design is?
I don't think that exists yet, but
Yet.
that would be
Yet.
super cool.
One day.
Yeah, one day. Get on it, programmers out there.
I would just go
I'm
back
sure
to
you can figure it out.
what's it called, generative design, just see what comes out of there.
Yeah, well, there's that.
It's true. Anyway, our next segment we're going to move away from the 3D printing applications and the tips, as fun and nerdy as that is. And Ben has a comment for us. We're going to start responding to your comments live on the podcast. So, Ben, would you like to read us the comment?
I don't have my reading glasses, but I'll do my best.
Okay.
I'm actually going to paraphrase this one. Wouldn't it be really cool to have like 5 or 6 axis machines to print really strong structures that don't just print in a planar, what is it, a plane? Maybe I should
Planar,
read
yeah.
it. Yeah, planar. And print in like multiple levels in different directions to have a really cool print. And that's wicked strong. I thought that'd be cool.
That does sound cool.
Actually, I can't take credit for it. I didn't attach their name. I will give credit somewhere to you.
Ben will add a screenshot of it to this podcast. So if you're watching on YouTube, you can see who left the comment and its full glory.
There you go.
I do think that would be really cool. I know Stratasys has a demonstrator that does something very similar to that. I think they call it the Hydra, where it's a 7-axis 3D printer. Most 3D printers 3D print just in layers, one on top of another, and this makes parts that aren't uniformly strong. It's a lot like the grains in a piece of wood, right? And so it's stronger or weaker depending on the direction that you apply the force. But if you add more and more axes, in theory, you could draw lines in a way that eliminated that.
I was going to say, how far is that from just being a robotic arm of the pen, really, and just being like the pen?
No, that's
Those are two
basically
different
it.
things.
Yeah, basically it.
It's
The
what
robotic arm, that still prints on one plane at a time, then it goes to the next layer, just has a bigger print area. The pen, that's not on a robotic arm, right? That's usually just handheld. And I think this person's talking about a robotic arm
with an
with,
extruder.
With an extruder head.
Mm-hmm.
Yeah.
That's the first I've seen that before. At a trade show in Chicago, Fanuc had a robotic head with
really?
an articulator on the end that made their little logo in plastic and stuff at the demonstrator. But
I guess it already exists.
Yeah, I
Cool
would.
to test.
well, in some cases, I'm sure.
I
you
would
could do that.
say it's just not very mainstream yet. Like I don't know of any products that you would necessarily go to and just go buy off the shelf right now.
Well, you're not working from Cartesian coordinates to print something, so you don't have something uniform. You'd have to have a robotics engineer who could program what you wanted it to do, which is probably the bigger challenge.
Or a CNC program.
It'd be similar in
Potentially.
nature to like 5-axis CNC. Yeah, I would say that the technology exists. It's just not super common yet.
Yeah, I'd say it's mostly at an experimental stage, and probably the biggest hurdle to it becoming more mainstream is the slicing element, the programming, the translating your model into instructions for the robot to follow. A lot of that software either doesn't exist today, or it's experimental and difficult to use, or it's super expensive. And so we haven't seen the hardware become available because of the limitations of
And there's
available software.
an added skill level, like when you think of CNC, to operate a 3-axis CNC versus to operate a 5-axis CNC. So getting enough people trained to be able to operate that kind of system.
What do you think the benefit is?
Stronger parts.
More uniform.
No support material. Because you can just rotate the model and then print vertically again. So right now, all the printers in this room have a model material and a support material at a minimum. And so you can like eliminate that completely. Therefore, you eliminate some of the post-processing aspects of it. I mean,
But
that alone would save us a ton of time.
If you've got a stationary overhang, you need to print fill material to hold that
Yes.
overhang up, but instead you would just
rotate the part.
come up.
Yeah.
Cool.
I've seen a couple demonstrations, including the Stratasys one, but I think like this commenter pointed out, it's not mainstream, and it's something that we can look forward to eventually once kind of the software and hardware all comes together. The building blocks are there from CNC, so it should be very possible.
Cool.
Yeah.
That's exciting. I didn't know we were as far along as you just told me.
Yeah. You're welcome.
I thought
man.
this was like way in the future.
No, it's a cool thing that we can look forward to. But instead of just looking forward to the future. Kevin has our next segment,
Oh.
a throwback to what we've been doing for all of our other podcast episodes with a current news story.
Well, we don't want to completely disregard because progress marches on, whether or not we choose to talk about it. But it was really hard not to find something in the news related to the coronavirus. So guess what, guys? 3D printing and the coronavirus. How do those things tie together? So it's not necessarily in the way that you think. This isn't about supply chain disruption. This isn't about people staying inside and 3D printing their wares because they're afraid to leave their houses. It's about the University of Hong Kong Polytechnic University.
Okay.
And they are printing personal protective equipment that is in short supply now that a lot of consumers are buying what would otherwise be hospital grade materials. Hospitals are running low on personal protective equipment. And one of the ways that 3D printing is contributing to the treatment of people or the prevention of spread of the coronavirus is by 3D printing some really cool stuff. So they have some pictures on here. I'm sure you guys can see it. I don't know if we can get the pictures pulled up there, but they are working with local manufacturers to basically print face shields that will come down and prevent healthcare workers from getting exposed to people with potentially the coronavirus.
See, I don't usually associate face shields with healthcare. I usually think of like welding.
So if you think about it, yeah, I mean, you do have like a welding face shield, but I think depending on, you think healthcare workers and you think like the thin paper masks.
Yeah.
So what these are more like visors with plastic shields that come down in front, where you might have like in an operating theater, or you might have in a triage station in the field, where you're not like in a clinical setting of a hospital where you can have traditional PPE available. So where you have like field hospitals springing up in remote parts of China, that's very, very necessary out there.
Yeah.
I have that exact same thing we're using with my angle grinder.
Face
Wonder
shield.
if they could just go to the equivalent of Home Depot, maybe? Are those all sold out too?
Maybe. Yeah, I think the lack of PPE for healthcare workers is something that we're seeing.
It's
here.
scary that it dries up so quick.
Yeah, I think the people just get scared and they start hoarding it in a way.
Mm-hmm.
But it's sad. I mean, it's great that 3D printing can come to the rescue.
Can kind of
but
help
it's
a little
sad that
bit.
We're in this situation. I think some of the numbers that they threw out there were really impressive. Like within 10 days, they were cranking out hundreds of face shields.
Yes.
With 3D printing. So I think that is a good testament to how flexible 3D printing is.
Their production is currently at 10,000 pieces per day as of February 28th.
No.
That's what they say.
Okay,
So,
that's
okay,
pretty
3D
crazy.
printing isn't fast.
So here's my theory. When I read that article and I saw...
I read it wrong. Hold on. Over a 10-day period, their 3D printers created 700 eye shields and 800 face shields. Not 10,000.
10,000 a day.
I don't
is
do
much
math well.
different. Much
So
different.
even in that case, when I read that, I would have approached it a little differently. One, it doesn't go into detail of what they're printing, but I think in the example they had on there, they're just using what looked like PLA, which, from at least my knowledge and my very limited medical knowledge, is not a good material to use in a health setting.
So yes, they say it's a inexpensive PLA filament material, but then they're really that is just serving as the visor portion, and then they're just attaching a piece of plastic.
And they're
in the front.
disposable, right?
Yes.
True, that's the second part.
Yes.
They're temporary.
Also, I believe we talked about in the last podcast a antimicrobial
Yes.
3D printing material. That'd be a really cool one to use for
And
this.
they actually do mention that there are the very thing we were just talking about. Advances in 3D printing technology that now print things that are resistant to retaining those things. They say the coronavirus can live on hard surfaces for 9 days, and this potentially, if you don't have,
I didn't know that, Kevin. I'm scared now. That's a long time.
I'm a little surprised, though, when I read it. I'm a little surprised they didn't go with the technique of printing a mold. Because I feel like you'd be able to produce faster than... See, that's where, again, we talk about economies of scale. It's faster to 3D print a mold, and basically you could, like, not silicone mold, but do some kind of medical-grade safe plastic.
Do they have access to injection molding where they are?
Well, it doesn't necessarily have to be injection molding.
Ben. They're in China.
Well,
it's
here's
China.
the thing. Kevin and I were
No.
looking at a map this morning that you showed me.
Yeah.
Of it looked like a weather map almost.
Okay.
And it was a before and after.
It was over the country of China, and you could see gradients of colors where it was lighter and darker over metropolitan areas.
Okay.
I didn't mean to cut you off.
Actually, you can explain it better.
well,
You read the article.
and,
I went to
and
the
it
picture.
was one was very, very, very dark. One was almost non-existent, and it was showing the amount of emissions that have changed
Yeah.
from January 1st through 10th till February 10th through 12th or 20th or something like that. And it was, here's everyday China, here is coronavirus China, and it was night and day. It was if it's you've seen like satellite images of lights all over the city.
Yeah,
That's
yeah.
what it looked like, and then it was like, oh, now they're without
Their
power.
industry has shut down.
Yeah.
So I don't think they
It may
even
not
have
be
enough
available.
manpower to actually do a mold.
Well, this isn't injection molding. This.
But it also might be preferable to have something that's disposable too, from
Yeah.
your part.
I wasn't really getting at the disposable as much as I still think it's faster to make the mold and pour as opposed to having to keep printing parts over and over.
Yeah, it's definitely possible. I think another aspect of this is the customizability. I don't think they went in depth into this, but
No.
like everyone's got different shaped heads, right?
Yeah.
And so you
Can't
can
do one size fits all.
right, or at least you could print 10 different sizes, and then you don't have to make 10 different molds, and then you gotta manage which ones you're
a good point.
pouring and the cure times and stuff. So that could be another advantage.
What else do you think they should print?
You know, I'm not a doctor, and I don't know a whole lot about medical PPE, so I have no idea.
I think it would be cool to have, like, if you have a fabric or something, anything is better than nothing, I assume, maybe, that holds
Don't
different-
take medical advice from us.
Oh God,
Yeah.
no.
No, just that holds different possible masks that they buy that fits really well to their face, snugly on their face. Because I heard in the radio that you can't have or open air on your mask, or it won't be as effective. So if you like had a good mold or shape of your face and then put the filter over it, that'd really be cool.
That would be
And
cool.
I think more effective.
Makes sense to me.
No clue.
I don't know.
Thoughts, Ken?
Well, look at that. We found a way to work in the
clue.
coronavirus to the podcast, guys.
Yeah.
Look at that. No, what I really appreciate about that article is I feel like most things I see are things like, oh, events are being canceled and production delays are happening.
Right. A lot of bad news. A lot of scary stuff.
A lot of bad news and scary stuff. And this was, I think, good news in that technology is stepping in to help healthcare workers and work our way through these problems that we're facing.
Know what event
I
wasn't
appreciated
canceled?
that. What?
No event wasn't canceled?
What?
Wasn't there a big 3D printing conference in Japan that wasn't actually canceled? So everyone still had to go to their booth. And there was like 10 visitors for the whole day.
It was like a general tech
The
conference. I
Geneva
thought.
Auto Show was canceled for the first time
I saw
since
that one,
World
yeah.
War II.
Wow.
It's only been canceled twice since
Not even
1902.
for the Spanish flu, which was probably worse.
Yeah, anyway, if I was going to say if you're worried about the coronavirus, regardless of if you're worried or not, please follow World Health Organization CDC guidelines and stay healthy.
Don't listen to
people aren't
us.
listening to us
We
for
just-
advice on
no.
where to go.
I don't know. Be smart out there, everybody. At this point, I think we've covered just about everything. Thank you for taking the time to watch or listen to this podcast. If you enjoyed it, make sure to hit the like button, subscribe to the channel, do all that normal YouTube, Spotify stuff, and we'll see you next time.
Have a good day.
Cut.